So welcome. In this session, you are going to derive the new tangential divided difference interpolation formula that can help us to carry out interpolation for non-equal spaced mesh points x naught up to xn. So derivation. Let y equals to f of x So let the values of the function at mesh points x naught, x1, x2 up to xn be given by f of x naught, f of x1, f of x3, all the way up to f of xn. Then by definition, we can define the first divided differences of the values x0 and x1 from definition. That the first divided difference of a general value x and this first mesh point x0, which can as well be written as f of x comma x0, is given by the value of the function at x minus the value of the function at x0 divided by x minus x0. So this is just from definition. So this we are saying that if we pick this notation, f x comma x0, to define the first divided difference of the argument x and x0, we have f of x minus f of x0 divided by x minus x0. Now, in this equation of the definition of the first divided difference, let's make f of x the subject. So we multiply through by x minus x0. So we'll have x minus x0 times f of x x0 is given by f of x minus f of x0. So which implies that when you make f of x a subject, we get f of x0 minus x minus x0 multiplied by f x comma x0, or simply the first divided difference of x and x0. Now let's call that one equation 1. Let's call this one equation 1. Now similarly, from definition, we have that if we define the second divided difference of the arguments x, x naught, and then x1, we get the first divided difference of x and x naught minus the first divided difference of x naught and x1 divided by x minus x1. So which implies that f of x comma x naught minus f of x, x naught, x1 is equals to multiply this by this function. So x minus x1 multiplied by the second divided difference of the argument x, x naught, and x1. So making f of x comma x naught the subject, we have f of x comma x naught is given by f of x, x naught, x1 plus x minus x1 multiplied by the second divided difference of x, x naught, and x1. All this one equation 2. Now what you're going to do, you are going to pick the right-hand side of equation 2 and replace at this point for x, f of x, x naught in equation 1. So replacing 2 in 1, we get that f of x will be given by f of x naught. So you see this f of x naught and then minus x naught really this actually is not minus but is plus, because you see taking this one to the left hand side will be positive, so this positive sign, not minus, so this plus. So we'll have plus x minus x naught into, so the place of f x x naught we replace by the right hand side of this equation 2, so we'll have f x naught x1 plus x minus x1 f x comma x naught x1. So let's open this. We get f of x will be given by f of x naught plus x minus x naught times the first divided difference of x naught x1 plus this by this will give us x minus x naught x minus x1 and then multiply by f of x, x naught, x1. So let's call this one 3. Now proceeding in this manner, we get that the general formula f of x will be given by f of x naught plus x minus x naught and then f x naught comma x1 plus x minus x naught x minus x1 multiplied by f of x comma x naught comma x1. Actually, remember then now for this case, yes, this what will have function of x and x naught x1 plus other several terms plus x minus x naught, x minus x1, all the way up to x minus xn minus 1 multiplied by f of x, x naught, x1, all the way up to x n minus 1, and then plus x minus x naught, x minus x1, x minus xn multiplied by f of x, x naught, x1, all the way up to xn. So this formula can be written as, so let's call this one 4. Equation 4 can be written as f of x is given by f of x naught plus x minus x naught multiplied by f of x naught comma x1 plus x minus x naught x okay, then you can just have plus other several terms in between. Plus x minus x naught, x minus x1, x minus xn minus 1, and then we multiply by f x naught, x1, x2, all the way up to xn. So this is by using the fact that if f of x is a polynomial of degree n, then the n plus 1 difference and therefore f of x, x naught, x1 up to xn will give us 0. So therefore now, let's call this one equation 5. And equation 5 is what we call the Newton's general divided interpolation formula. So this formula five is the Newton divided Newton's general divided difference interpolation formula. So in the next session, we demonstrate how to apply the formula 5. Thank you.